All right, let's dive in. Today, we're talking about the power of statistics. It's all about how we turn messy, raw data into clear, useful knowledge. So let's get right to it. We're swimming in numbers every single day. Charts, data, figures, they're everywhere. But how do we cut through all that noise? How do we find out what's really going on? Well, that's the big question we're going to tackle, and statistics, that's our best tool for the job.
So, to really get what statistics is all about, we've got to go back in time. And believe it or not, its origins are, well, pretty royal.
The science of kings. How cool is that? I mean, think about it. Kings and emperors needed to know what was going on in their kingdom. How many people, how much land, how big's the army? They were making huge decisions based on data. So really, from the very beginning, statistics has always been about using numbers to get a handle on the state of things. And that basic idea from way back when, it leads us straight to the definition we use today. See, statistics isn't just a bunch of boring math. It's a process, a method. First, you collect the data. Then you present it, analyze it, and finally, this is the big one, you interpret it. And what's the whole point? It's simple, to make smarter, better decisions. Okay, so first step, collect data. Sounds easy, right? But it brings up a really basic question. Who or what are we even collecting data from? And this is where we hit a super important distinction. First up, you've got the population. This is the whole enchilada, the entire group we care about. Let's say we want to know the average height of students at a university. The population isn't some of them, it's every single student enrolled there. All of them. Now, trying to measure every single student in a massive university, it's pretty much impossible, right? So what do? We do the smart thing. We take a sample. Maybe we grab 100 students. But here's the key, and this is crucial. That sample has to be representative. It needs to be like a perfect mini version of the whole university. So here's the bottom line. You study the small, manageable sample so you can learn something real about the huge entire population. It's exactly like tasting one spoonful of soup to know if the whole pot needs more salt. You don't have to drink the whole thing. Okay, so we've got our data from our sample. Now we're just staring at a list of numbers. The very first thing we usually want to know is, what's a typical value in this list? Is there one number that can kind of represent the whole group? And for that job, we've got three main tools in our toolbox. There's the mean, which is what we all learned in school as the average. Just add them all up and divide. Then you've got the median. If you line up all your numbers from smallest to biggest, it's the one right smack dab in the middle. And the mode? That's the easiest one. It's just the number that pops up more than any other. But that leads to a really good question, right? Three tools, but which one do you pick? And let me tell you, the choice you make can matter a lot. Let's see why. All right, let's put this to the test with some salary data. Imagine you've got 4 people making around 50 grand a year. But then you've got their CEO who's pulling in 500 grand. That huge salary, that's what we call an outlier. And just watch what it does to our mean. It yanks the average all the way up to $143,000. That number doesn't really represent anyone. But now, look at the median. It just looks for the middle value. It sees that huge number, but it doesn't care. It stays right there at 55,000. Now that feels like a much more typical salary for this group, doesn't it? And that right there is the big takeaway. The mean gets totally thrown off by extreme values, but the median, it's robust. That's exactly why when you hear news reports about income or house prices, things with big outliers, they almost always use the median. It just tells a more honest story. Okay, so we're getting good at this. We know how to find the center of our data, but that's only half the story. Seriously, if you really want to understand what's going on, you also have to know how spread out the numbers are. And if you're wondering why that matters, just look at this. We've got 2 cities, City A and City B. And get this, they have the exact same average temperature, 25 degrees. But here's the question. Would you pack the same suitcase for a trip to both? No way. City A is super consistent, but City B, it's all over the place. So is knowing the average enough to describe these 2 places? Absolutely not. The average gives you zero information about how consistent or how variable the data is. Finding the center is great, but understanding the spread is just as critical if you want to make a good decision, like, what to pack. And there's a name for this idea. It's called dispersion. It's basically a measure of how spread out everything is. It's the number that tells us the difference between predictable city A and totally unpredictable city B. So remember this. To really describe a set of data, you always need 2 things, a measure of its center and a measure of its spread.
So far, we've been looking at one thing at a time, right? A list of salaries, a list of temperatures. But what happens when we want to see if two different things are connected? Well, that's when we enter the really cool world of correlation.
Let's start with a positive correlation. It's pretty simple. It just means that as one thing goes up, the other thing tends to go up too. A classic example is the hours you study versus your exam score. Generally speaking, the more hours you put in, the higher your score is going to be. Then you've got negative correlation, which is, you guessed it, the exact opposite. As one thing goes up, the other tends to go down. Think about, say, the hours of TV you watch the night before a test. The more TV you watch, the lower your score might be. The relationship might be weak, which just means the data is more spread out, but you can still see that general downward trend.
And then, of course, sometimes two things have absolutely nothing to do with each other, like the number of pets you have and your final exam score. Yeah, probably no connection there. If you plotted that, the dots would just be a random mess. There's no pattern, no story to tell. All right, let's take a step back and put all these pieces together. We started with a big question, how do we find truth in numbers? And now we have a whole set of tools to find the answer. We've basically followed the entire statistician's journey.
And here it is, the whole process from start to finish. First, you collect your data from a population or a sample. Second, you describe that data by finding its center and measuring its spread. Then you look for relationships using correlation. And finally, you get to the most important part. You interpret everything you found to make a smart, informed decision.
So you see, from the science of kings all the way to the tools we can use every day, statistics gives us this incredible framework for making sense of the world. So from now on, when you see a chart online or hear a statistic in the news, stop and ask yourself this question. What story is this data really trying to tell me? Because now you've got the tools to figure it out.